I can move my post-it. I've just turned the recording on. So I'm Peter Smallage. I'm the New York State Extension Forester. I want to welcome you all to this webinar, and I'll be introducing Dr. Nyland in just a moment. I want to kind of orient you to the screen. On the right-hand side, you see at least two panels. One is a participant panel, and you can click on the tab that shows to view all attendees, and then the chat panel is in the bottom. So you can, when you send a chat, please do so to all participants so that that question doesn't have to be reread and it's there. A nice feature of this software, this WebEx software that replaced the previous software, is that you have the ability to save this presentation. And as you'll note on this opening slide, you're not authorized to disperse it or use it otherwise without the written expressed consent of Dr. Nyland, but you can save it for subsequent viewing. You do that if you click in the upper left-hand corner on the File menu, and then go to either Save or Save As, and you can save the document. And when you save it, you have the option of saving it either as a save it as a PDF file or as a UCF file, which is a Universal Communications format.
Peter, it's Ralph. I need some help because I'm getting the Cornell sign, but not the first slide of the presentation.
Oh, that's because you're the presenter. All right, so click on the Rehabilitation tab, Ralph.
I did. Oh, good. Thank you.
Okay, so see, I made you, so I can change, I can look at it. Yeah. Actually, anybody can look at anything is the way I have this set up. But they will, okay, so since you're the presenter, what you click on, everybody should see. So people should be seeing the first slide that says Rehabilitating Disturbed Forests. Can somebody confirm that's what the attendees are seeing? All right.
Well, I can see it, yes. All right.
Okay, good. So, all right, great. Okay, well, so wealth and world of experience in dealing with silviculture, and I spent a lot of time thinking about and developing strategies on how to rehabilitate one of the common features of our hardwood forest, the high-graded phone off and turn the floor over to Dr. Nyland. Thank you, Ralph, for joining us.
Greetings, everyone. It's good to be here. At Syracuse, we've had some rains today. A couple of years ago, some of us met on this venue and talked about some early thoughts on rehabilitation. So today, we'll bring it up to date and expand on some of the ideas that have been emerging. I see that many of you are landowners, and so thought it would be good to start with a few general definitions, just to make sure that when I use a term, you're thinking the same way. So these terms will deal with forests and their management and use. And the first one would be forestry itself. Note the three words here: science, art, and common sense. The common sense is critical because this is a practice, and we're trying to create, to manage, to use, and conserve forests. But we're doing this to sustain the values long term. And then forest management, a subset of forestry, is that science of actually putting the goals to work, doing the things that bring the hopes of a landowner to fruition, and sustaining them into the future. And then silviculture, the real subject of our discussion today, are those methods we use to control establishment of new trees, the growth and development of trees and stand, the composition, which means the character as well as species and the quality of stand, and sustain those for human benefits, to serve an objective, that of the landlord. In the past couple of decades, we've put a lot of emphasis on a thing called ecosystem management. And if we define silviculture in that context, then we talk about creating, maintaining, and reestablishing desirable ecosystem conditions. It's the conditions in the forest. And we use stand level treatments then, landscape level interest, one stand at a time through silviculture. So as an aftermath of using silviculture stand by stand to create and alter and influence broad ecosystem conditions, we will have to cut trees. We will have to manipulate stands, and we'll have to use, that's where we'll derive some commodities that we can use to pay the costs of management ownership. But the emphasis now is on creating and maintaining those ecosystem conditions, not managing uses per se. Silviculture, we deal with stands, that unit of forest land that we can identify as having a common condition that leads us to a common treatment throughout. And so it's the area we would manage by timber sale or by intermediate treatment someplace as a single. So with silviculture, we really only try to do two things. One is to regenerate mature age classes when they've reached a stage of development that we consider mature, and the definition of maturity can vary depending on interests. But part one then is to regenerate mature age classes, and the other part is to tend immature age classes, to focus the growth onto the trees and forest conditions that serve the interests of an owner, to nurture that stand until it becomes mature, and then we can regenerate either an age class within the stand or a whole stand. So timber harvesting simply is a means to an end. It is in fact the way that we accomplish these purposes of regeneration and tending. So it's a tool of silviculture. And recognize that through research and experience, we've developed a whole huge tool bag of techniques that we can use to create, maintain, encourage different kinds of things. It's the way we go about regeneration and tending in different kinds of contexts to serve the interests of the landowner. We've recently been thinking about rehabilitation and how that fits into silviculture and the alternatives that silviculture would be applied for, particularly taking ecosystem management into context. And we're recognizing three broad pathways that silviculture might follow. One would be restoring. One of my colleagues up in Quebec recently said that she had bought an old house and had to make a decision. One would be to restore it to the way it was in 1980. And if she then went back and took out the plumbing and re-established all of the things that were there for the first owner, that would be restoring. The other pathway of silviculture would be refining. And this is the bulk of silviculture activity as we've historically known it. It's taking conditions, we find them, and recognizing that by enhancing them through manipulations of various kinds, we can better serve the interests of an owner. But we're trying to sustain existing conditions. And the third is the rehabilitation. And that's where some disturbance has caused a loss of some conditions of interest, values of interest, and now we're trying to get those back again. This is not taking the 1795 house and getting rid of the plumbing, but it's finding a way to fix the plumbing so we can live in that house. So there are three pathways of silviculture. And today we want to focus on rehabilitation. Why rehabilitate, what we're going to rehabilitate, and how we might go about doing it. Here's a definition to think about. We're putting the emphasis on ecologically acceptable methods. That links us back into the concepts of ecosystem management. And we use those methods to reestablish desirable conditions after an uncontrolled disturbance. And that uncontrolled disturbance is the key of deciding here's where rehabilitation is needed. how we rehabilitate them will depend upon the interests of a landowner. Well, if we use that as a definition, then there are several natural or people-caused disturbances that might warrant rehabilitation. As an example, ice and snow loading. Many of us remember the ice storm. The picture you see was one of the aftermath. Rehabilitation was appropriate in those stands. We don't have stand replacing events in northeastern North America following fires, but they do cause partial mortality. Some kind of rehabilitation might justify that. The forest insect, the forest tent caterpillar infestation of the mid to late 2000s, that was a case of a natural disturbance. And cutting practices, these are probably the most widespread of the disturbances we have, and they're ongoing and never ending. And note this about diameter limit cutting. The most common way that people are manipulating their forest, this is an uncontrolled disturbance from a silviculture perspective, and hence the subject for rehabilitation. So let's explore some ideas about rehabilitation and focus primarily on the effects of diameter limit cutting and what that has done to the forests of northeastern North America. So, how much goes on? What other kinds of exploitive harvests are out there compared to silviculture? And what does it leave behind compared to silviculture? We have a start at appreciating the effects and extent of diameter limit cutting in particular by a survey that the New York Society of American Foresters did in the mid to late 90s. You see on the screen a map of New York with little white spots on it. Those are the randomly selected timber sales that were investigated or checked after the fact by SAF members. In each stand, we looked at 5 conditions: the resistance per acre, the variation in that stocking from one sample point to another, if the stand had desirable species left behind, what happened to the change in the average diameter of the stand, and what happened to the saw timber potential. And then we combined those into a composite value so that we rated the stand from 1, which would be really good, to 3, which would be really bad. We had specific criteria. Here you see a list of the checklists that we used, and by interpolating between, say, good and mixed, we could give values to the nearest tenth of a point. So the scale then for compositing these 5 values was then on a scale of 1 to 3. And here's what we found. On these screens, the good is on the left, and the poor is on the right, and 3 is the worst score that we could have given. And we found about 2 out of 5 of the post-harvesting stands that were visited at random fell into that good category. So these are stands where we could practice routine silviculture. We can sustain the values through time by those practices. It might look like this: high potential for the future, high potential for sustaining these values into the future. About half were of questionable condition in that middle category of not good, not really poor. And the question was that with a little creative silviculture, perhaps these could be rehabilitated. These could be brought into a more productive state. I call this silvicultural purgatory, and the notion is that it will take some very creative thinking to bring them into a better. And here's 13%, what, 1 in 7 or something, that were really poor. These had been essentially ravaged. Stands look like this. The value taken out, the condition of the trees left behind are not only poor for quality for saw timber, but many of them dying back. These are degraded and dismal stands. They're ravaged. Commonly, these are stands that had at least 2 diameter limit cuts. The ones in the middle group, 1 diameter limit cut. These in the poor group, at least 2 diameter limit cuts. Now, there have been other surveys that have looked at the nature of post-logging conditions across northeastern North America. One of the early ones was by Pell in Pennsylvania. That study, he questioned the potential for long-term sustainability of the stands. Marianne Faven in West Virginia, she looked at were not sustainable based upon the practices that she observed. McGill in West Virginia, diamond limit cutting, the most severe practice he found. Munsell and Germain in New York, essentially stands left behind were mediocre and not sustainable. And Schuler and McGill in Appalachia, diamond limit cutting had depleted the quality reserves of saw timber. Stringer in Kentucky, 72% degraded by exploitive harvesting. And then a fairly recent one by Munsell and Germain and Bevilacqua, diameter limit and premature cutting were pervasive. It's common. This is not something unique to New York. And one then raises the question, is this forestry? Or is this what my mentor once called the green lie? It looks like a forest, smells like a forest, but it's really just a pretense for the real thing. Stands, it's been taken out, the production potential has been lost, it's long gone. And what do you do now? Where can we go into the future to try to get those sheep back into the barn? There's no clear way that we found or anybody's proposed for evaluating the ecologic impact of having gone from a productive stand to one that's been ravaged by exploitive harvesting. But we can look at things from a production potential relative to wood volume production and see how that might work out here. So how did cutting change stand conditions? And then ask, do the residual conditions we found dictate or limit the treatment options that we could use for moving into the future? And let's pause here and make sure that my definition of uneven aged and two aged are consistent with what you're thinking. Let's start with even aged. And by definition, the trees have only a small difference in ages. They may have different sizes, but they have only small differences in ages. And the convention is that the range of ages would not exceed 20% of the intended rotation length. So what's a rotation? That's the number of years that we plan on from the time we establish a new even age stand until we regenerate it at the time of maturity. So if we had a 100-year rotation in mind, an even age stand would have a spread of ages not exceeding 20 years. The stand grow, these even age stand grow in clear patterns, starting with small trees and lots of them. They develop through Middle Ages. The numbers of trees decrease through natural mortality, large and big. And this period of transition can last for 150 years even in this even age state. If you have a forest comprised of even age stands, it would look like the diagram on the screen. Each stand having a narrow range of ages. You can have stands of different ages. And the way we get a balanced condition across an even age forest is to have an equalary in stands of each age class. Some 10-year-old stands, some 20-year-old, 30-year-old, etc. So in even age stands, all the trees regenerate at the same time. They all develop to maturity together. They all come of age at the same time. And so we're going to handle it as a unit. When they're young, we will tend the immature trees primarily to reduce crowding, to focus the growth potential on the best trees of the stand, and we call that thinning. Thinning favors the biggest development into the future. And here's an example of a stand that's approaching a century mark that has had 3 thinnings in it. So then the stands reach maturity, maybe at the century mark, and it's time to regenerate them, to take the existing stand and replace it with a new one. And there are different ways we can do that. I'm illustrating here the shelterwood method, where we choose at regular uniform spacing the best trees of the stand, keep them at wide spacing, use them as a seed source, use them to provide some modification of the environment near the ground, establish a new cohort beneath them, and then once those new trees are established and of some minimum size, we will take off the older trees and have a new even age stand to work with in the future. Here's an example of what a shelterwood seed with the new age class formed beneath it and approaching a time when those older trees would be taken away to leave the new even age stand. Now, in sharp contrast, even age is uneven aged, where the trees differ markedly in their ages, and the convention here is that the spread of ages exceeds 25% of the planned lifespan for an age class. We don't have a rotation with the uneven age, we have a lifespan. We're going to grow an age class to maybe 100 years of age. And if that's the case, then we have at least a 25-year spread of ages within the stand. So the stands would have trees of different ages, which are of different sizes, not just different diameters, but different heights. And generally in managed uneven age stands, the proportional total height in live foliage would be, in an even age stand, it's commonly maybe only 15 to 25%. So if we have a stand, it would look like this with the intermixing of age classes. And remember now that only one of these age classes reaches maturity at a time. And that's the age class we would remove to regenerate a replacement age class. And across the whole forest, if we had nothing but uneven age stands, it would look like this. Again, all the trees start at different times. Middle, young, and old trees are all present, intermixed, and only one of them comes of age at a time. So within uneven age stands, we would regenerate and tend simultaneously every time we enter, remove the intermediate age classes. Regeneration and tending together. Here's an example of the regeneration. It's called the selection method, where we take out some big trees. You notice the light spots on the ground. We're trying to create an environment for establishing the new age classes. And here's a picture of the stand which has had a combination of regeneration and tending. And this particular stand has had 2 entries under selection system. Now we have a third kind of stand that's called 2-age, and these have 2 distinct age classes. They're not common, but the notion would be that the youngest and oldest age class would have an age difference of at least 20% of the lifespan for any one of them. So they would look like this. There'd be some big trees, which are old, and beneath them, a younger age class. Of course, that younger age class will grow and develop through time. Consider the older age class mature. We will remove that to regenerate a replacement age class and keep the immature ones that are present to grow into the future, and repeat this entry process maybe at half-century intervals or something of that order. Here's an example of a 2-age cut where the oldest age class is taken away, the intermediate age class is left behind, and you see the regeneration forming beneath it. So there's the process. And we start over again every half-century or so. 2 distinct age classes present. Great difference in the age between the 2. Each comes of age at a different time. Now, the New York survey, we did not find 2-age stands. So we just have to be aware that there's an opportunity to think about that as an alternative for the future. So let's go back to the New York timber harvesting evaluation and begin to pull it apart, to dissect some of the findings and see what it might tell us about dealing with the stands that have had some sort of a disturbance. First off, within New York anyway, we did not find that the cutting had taken out all the good species and left only poor species behind. In the northern hardwoods that covers most of our state, sugar maple is the backbone tree. So in the even age stands, the black cherry and the white ash would have been taken out perhaps, but the sugar maple left behind. And essentially, the cuttings tend to take out the trees of less shade tolerance because they grow more rapidly. So a diameter limit cutting would take out the aspen and the black cherry and the white ash, leave the beech and maple behind. Sometimes it takes out the birch as well. Leave behind species we can work with. In uneven age stands, they already are dominated by sugar maple, so cutting mostly left behind sugar maple. For the other parts of the assessment, I want to use a series of diagrams like the one you see here. There will be the vertical axis, which shows some sort of a change, and the horizontal axis is a stand rating, good on the left, poor on the right, and then some kind of a line which depicts a trend among the data. Okay, let's start with change in the average stand diameter. We call this the quadratic stand diameter. It's the diameter of the tree of mean basal area. In most silviculture treatments, we try to increase the quadratic stand diameter or reduce it only slightly. If you're taking the oldest age class out of an uneven age stand, it will drop down a bit, but not dramatically, just by a slight amount. Pound. Again, remember, the good stands are on the left, the poor ones on the right. And this shows that as we went from a index value of 1 to 3, the quadratic stand diameter got lower and lower and lower. The big trees taken out, the little trees left behind. It's a good indication of the extent of diameter limit cutting across the stands we subject. Here, an even age stand. Diameter limit cutting, we take out the big trees, leaving the small ones behind. There's a picture of it, an actual diameter limit cut in an even aged stand. And in uneven age stands, now here we're taking out the oldest age class, maybe the older 2 age classes, and leaving behind the younger age classes. That's a big difference. So here's an example of diameter limit cutting in an uneven age stand. It's not pretty. Now, what about the change in the growth potential? And it's particularly important to remember the difference here between even and uneven age stands. Let's start with the even age stands. There's an example of one after a diameter limit cut. In even age stands, we assign trees to different crown classes based upon their what some people call the social position, how tall and big they are compared to others. So the biggest and best trees, the ones which crown emerge above the main part of the canopy, we call those the dominants. These are the trees that grew fastest in the past. They generally have the best quality. They're genetically the best. The most of the trees in that upper part of the main crown canopy are co-dominants. These are genetically good. They're good trees. They grow well. They have good promise. They just didn't grow quite as well as the dominants. Bottom part of the crown canopy, in the little cracks between the co-dominants and dominant trees are things that are intermediates. These are genetically poor. They have grown poorly in the past. They have poor conditions. They have little promise for the future. And the worst of them are the overtop trees. These are wretched in all woeful way that you can think about. They're just stuck down in the bottom, hardly staying alive. Or how about the growth? These are data taken from sugar maple after thinning, 15 years after thinning. So the dominant and co-dominant trees grew quite well. In that 15-year period, the dominants added nearly 3 inches, the co-dominants about 2 inches, the intermediates 1 1/3 inches, and the overtop trees about 2/3 of an inch. You see the implications? That if you take out the dominant and co-dominants, you're removing from the stand the trees with the best growth potential, the ones that would grow well. And remember that in these crown positions, the dominants are bigger in diameter than the co-dominants, are bigger than the intermediates, are bigger than the overtop trees. There is a direct correlation between the diameter of the tree and the crown position. The bigger, the better. Here's some absolutely new data. We just generated this based upon 2 sets of thinning plots, one at the Ranger School in Wanakena, New York, and the other at the Huntington Wildlife Forest near Newcomb, New York. The vertical axis shows the average annual diameter growth. This is over a 20-year period. And the horizontal axis shows the tree diameter, even age stands. These are at 60% relative density. You see the difference? An 8-inch tree is going to grow about what, 0.105 inches, and a 20-inch tree is going to grow at about what, 0.1. If you cut the big trees, you're going to get poor growth by what you leave behind. And the stand density makes a difference. These are 3 levels, high, medium, and low density. You see that the stands cut to the lowest residual stocking, the trees grow the best. But still, the small trees grow poorly, the big trees grow better. Once a runt, always, it's like pigs. The runt never gets more than that. So here's an example of diameter limit cutting where the dominance and co-dominance have been taken away, and the trees that are left behind are smaller with a poor growth potential. You also notice that the quality is kind of mediocre in many of these trees. That seems to be related to crown position as well. Now contrast that with uneven age stands, where the trees of different sizes, there are different ages. The big trees, the young trees are short and small in diameter. Here's some growth work that Diane Kiernan did. These are stands at 2 levels of residual stocking, 65 square feet and 75 square feet base layer. Trees grow better at the lower densities. Now notice the difference here. The smaller trees, the younger ones, actually grow better after cutting than the bigger trees. Isn't that interesting? See the contrast in the uneven age stands? We're getting about 2 inches in a 15-year period for the saplings and poles, and about 1 2/3 out of the bigger trees. So the consequences of diameter limit cutting would be quite different if it's applied to an uneven age stand compared to an even age stand. With uneven age stands, diameter limit cutting, but it does leave small trees with good growth potential. And the key in uneven age silviculture is to control residual stocking and the spatial distribution of trees. Those are the things that have an important effect upon stand level production. Now what about tree quality? Would it be sufficient to sustain future management and provide people with products of value? The numbers of good trees and their condition will determine the options. In the New York assessment, we did not use a very high standard. We used a minimal standard that would a tree produce at least 1 saleable factory grade log at the time we would think about harvesting it. That's not a high standard. Well, what did we find? Here's again that diagram where good is to the left, poor is to the right. Shows that as we went from the good stands to the mediocre stands to the poor stands, the amount of total acceptable growing stock left behind is less and less and less. And here's just the saw timber component. The same trend line. So we go from the good to the mediocre to the poor, we find less and less and less acceptable growing stock within the stand. Diameter limit cutting takes the best out of even age stands, and it does the same thing with uneven age stands. Now patchiness is another. We measured not only the residual base layer, but the variation from one place to the next. We measured the stumps and converted them to pre-cut diameters, and thus we could tell how things changed. Patchiness changed, average diameter changed. Again, the good stands on the left, the poor on the right stands. The variation, we used the coefficient of variation to measure the variability. It went up a little bit, but not very much. But look at the trend line as you go from the good to the mediocre, the poor, the amount of patchiness increases. There were a few cases where patchiness actually was decreased. These were probably very carefully, intensively applied silvicultural treatments. But generally, as you went from good to mediocre to poor, patchiness increased. Here's an example of an even age stand. Given diameter limit cutting, you'd see these big open spaces within the stand. That's what we call patchy. Here's an example of it. Diameter limit cutting in an even aged stand. An even age stand Remember, we have intermixed age classes, but when you take out the older age classes, you get patchiness as well. Example of a uneven age stand that was given diamond limit cutting, taking the trees 14 inches and bigger, and you see the high degree of patchiness. We did not look at interference to regeneration, but really need to take that into account here. If we have interfering plants within the understory, that will prevent us from successfully regenerating new trees with some sort of a silviculture treatment. The general rule of thumb that's used today, if interfering plants cover a third or more of the stand area, then that's a problem, and you need to deal with the interference as part of the treatment for the stand. I want to illustrate with two groups of plants. To the left are species that we find beneath the existing forest stand, and on the right, two species that tend to emerge commonly after the fact. So ferns, for example, it's the ones with a single stalk, not the clump ferns, but the ones that come up as single fronds, and a very common one in northeastern North America today, beech root suckers in the understory. The striped maple and the pin cherry will develop often after cutting. Here's an example of a beech understory that interferes with not just the regeneration of trees, but the abundance of herbaceous species. You can see how naked the ground is beneath that dense beech understory. And we found that if you remove the beech understory, upper left done with brush saws, lower right, the aftermath, that's all sugar maple regeneration that formed within a couple of years after just taking the beech understory out without manipulating the overstory. So it is key to success where you have interfering understory. Here's a combination of some ferns and other herbs. If you find that, as commonly occurs in these really poor stands, you must deal with it before doing anything else. And the only way to deal with ferns and to deal with these grasses is with misblown herbicides. You can't do it mechanically. It just does not succeed. That'll be an early step in promoting regeneration. So the New York survey found 5 conditions that affect decisions we make about rehabilitating cutover stands. These are the mediocre and poor stands now. The change in diameter, the future growth potential, the quality of the residual trees, the patchiness, and the likelihood of interference. With the good stands, we don't have these problems too much. We must remain diligent. So those are not that's refining, that's routine silviculture. It's the mediocre and the poor stands that are subject to rehabilitation. When we look at all of these 5 together, patchiness keeps popping out as one of the key factors that's going to drive decisions and making predictions or prescriptions about manipulating stands in the future. Patchiness comes from this openness in some places and crowding in other places, but patchiness is also related to the irregular stocking of usable trees. Remember, the tree has to have some future value to a landowner to justify keeping it into the future with a rehabilitation treatment. So another factor here is that if you look at these diagrams, you see that the little spots are widely spread vertically. There is, for any one feature, one landowner to the next, despite having a common general score. So we concluded, at least I have, that in many cases a single treatment would be possible in a cutover stand. If it's really bad, you could remove the entire stand with a clear cutting and start again. If it's got only a few scattered trees, like in the upper middle, you could reduce the very low stocking and move it towards 2 age. If it's uneven age, you could go to low density conditions and try it into the future. But for most cutover stands, the patchiness and the stand-to-stand variation usually call upon us to do more than a single treatment throughout. Some work that Laura Kennefick is doing up in Maine where she's analyzed the conditions and applied treatments illustrate this point. Notice those are hardwood crop trees that were released by release cutting. There were some residual conifers that were left behind and tended, and the open spaces between these crop trees then had to be planted in order to get that something growing in those spaces. Remember, cutover stands have only a few good trees and often at wide spacing, and so commonly cutover stands require heavy treatments, heavy cutting to remove the dregs and bring things into a more operable condition. So one of the options might be to reduce the stand to very widely spaced individuals of the best condition. Uniform spacing would be desirable here, and to try to initiate a two-aged arrangement by establishing a new age class beneath them. The first step would look like on the left, where the new age classes. That new age class grows up between the widely spaced trees, and you have a truly two-aged condition. In some places and in some stands, the only option is to clear off all of the bad trees. I mean, there's nothing worth keeping there. And then use natural regeneration to give you a new age class. But remember, in most of our forest types in northeastern North America, it's important to have well-developed, well-distributed advanced regeneration of desirable species before you take the overstory off. Here's an example on the right where there was well-developed, abundant sugar maple advanced regeneration, taking the overstory off in one step led to a successful regeneration effort. I want to emphasize that point again. In many forest community types, to get successful natural regeneration, you must have developed advanced regeneration already in place. And if you don't, then you need to take steps to promote that advanced regeneration before you take the overstory away. This is true in northern hardwoods. It's true in oak communities. Just as two examples. Here's an example of a northern hardwood stand that was regenerated by complete overstory removal in the presence of abundant, well-distributed advanced regeneration. Under those conditions, it does work, given no interference in the understory. All right, so in some places you would clear off the whole overstory. In other places, there's not just advanced regeneration, but a new cohort that's developed partway. As you see, the understory larches here. And in that case, a release cutting to eliminate those dregs in the overstory, that would be, we call that a release treatment, that would be appropriate. In other places, you've got these clumps of a similar age class. They may have started in an opening that was created by a former heavy cutting. You might thin those clumps or entire stands if you can. Again, reducing them to very low density, wide spacing, because the trees that other trees have not got much value for the future. And in thinning, here would be an example of a stand-wide thinning to that effect. This is reduced to 45% relative density. That's a very heavy cutting, but by going to these lower and lower levels of stocking, you have more options to take out the poorer trees and leave behind the good ones. Here's an example in uneven age stands of using a low-density residual stocking. This stand was cut from 120 square feet back to about 65 square feet. There's different ages represented, but by cutting to these low densities, you can get rid of the poor and rehabilitate the stand. Here's the example of what happened. At the low densities on the left, you see the abundant dense regeneration that formed. 25 years later, it looks like on the right, where we've got a rehabilitated stand. Now, in some places, after diameter limit cutting, particularly the poor stands, the nature of the trees left behind are just awful. The vigor is low, they won't produce enough seed, the quality is low. In those cases, there's no advanced regeneration. You have no choice but to remove the overstory completely, remove any interference, and begin a stand conversion by planting, and probably to a conifer species, would make this kind of transformation. I'm suggesting conifers because we've not had very good luck in the past with hardwood planting, but conifer planting has worked quite well. more and more at stands that have been given these kinds of past exploitive harvests. Increasingly, we recognize that a multiple treatment option probably will be necessary to rehabilitate a single stand. It may be low density thinning in some even age patches. Don't worry about regeneration there, just thin them. In other places, you may do complete overstory removal, releasing advanced regeneration, or planting if you have to. You might do some shelter with seed cutting in patches to establish a new age class or a 2H. Cut to establish a new age class in those patches. And we've got uneven age conditions going to low density selection system cutting. It might look like this on the ground. This is the work that Jean-Martin Lucet is doing up in Quebec, where he integrates these different kind of treatments, 1, 2, 3 in this case, within a given stand. Some poor dregs left behind. The orange trees are the oldest, the green are the middle-aged, and the little bluish ones are young. A rehabilitation treatment might look like this. It's not perfect, but it's got things moving in the right direction. What's the other logical alternative? This is a rehabilitated stand. Notice it still is patchy. I had a wonderful mother-in-law who said, Ralph, you can't squeeze blood out of a turnip, and if there are no trees there, you can't put them up with Elmer's glue, but you can then create conditions in the openings to establish new cohorts to fill that space into the future. So rehabilitation will require a well-planned silviculture program based on a valid inventory. You have to do new and creative things. Forested system, reestablishing appropriate biological diversity, reducing the spread of invasives, reversing ecological chaos, and reclaiming the capacity for wood production. Regaining control, that's the essence of rehabilitation. Probably in many cases based on a multi-treatment strategy to capitalize on the highly variable conditions that are out there. So what's the real need? How do we overcome this bothersome past? Consider this new multi-treatment approach for cutover stands. Rebuild the chaos in a controlled and deliberate manner. Multi-treatment silviculture from the bag's many tricks. That's what's new. So, Peter, I guess we'd be open to questions or comments if people would like to make them.
Yes, thank you, Ralph. Great presentation. That was fabulous. And I think you did a great job, obviously, of covering kind of the foundation and defining the terms, and then laying out what the problem is, and then describing the different strategies for responding to those degraded stands. Could you maybe talk a little bit about the timing of when you want to? You mentioned controlling interfering vegetation. Does the timing of that, does it matter if you're doing it so the stand's been high graded, you have some interfering vegetation has developed or is present? Do you do that as, are there some general guidelines on, should you deal with the interfering before you do the rehabilitation cutting, during the rehabilitation cutting, after the rehabilitation cutting?
Well, there are some different views on that. My own, I would rather establish a new cohort, new seedlings, before I start manipulating the old. And you can't do that if the understory is filled with interfering plants. So I prefer to deal with the interference first. It's also easier if you're doing these broadcast treatments like understory mist blowing. It's easier to do that before you put a lot of logging debris on the ground. I think you can also get better coverage. Some people have preferred to do it afterwards, and then they find they have to come back and do a retreat treatment because they missed something. So I like to do it in advance. If there's trees in the overstory that will produce seed that you would find acceptable as seed production trees, then you can get a new age class started before you start manipulating the overstory, and use the overstory to provide some partial shade to control conditions. So my preference would be to do it first. I think it's going to be less expensive and easier to do it that way.
Okay.
And you can do it by if some people don't want to use herbicide, you can do it mechanically with brush saws. It's much more expensive. You can do it with basal sprays. You can do it with mist-blown herbicides. The one comment I will make, if you're dealing with beech understories, you need to get that chemical into the root system. And the compound that seems best in doing that is glyphosate. So common under the name of a quarter, similar compounds. So you want to know the species you're working with, and then go to the literature where people have tested different alternatives and use a mix of chemicals that will be fitted. Peter can refer you to a web page at Cooperative Extension where a bulletin there about treating beech understories anyway, and probably some other things as well.
Mm-hmm. And if you go, when just so people know, when they leave this webinar, they're going to be automatically dropped into one of the Forest Connect sites. It's the Cornell Ning site. And if you go to that and do a search just for herbicide or interfering vegetation, we've had multiple webinars and fact sheets and conversations about it. In fact, managing beech is one of the more common forum conversations that go on. So that cornellforestconnect.ning.com is a great place to go. There's some questions we have. Lou Ward, Ralph, do you want to look up from the bottom? Lou Ward had the first question about limiting factors in hardwood conversions.
Tom Ward.
No, above that, Lewis Ward.
Oh, there it is. Okay, Lewis, I've got you now. I think the key for me is establishing a new cohort, a new age class to fill in the empty spaces, to take the place of the really poor trees. If you have a good seed source, that's possible. Now, the problem with diameter limit cutting, particularly in even age stands, it takes the most vigorous trees out. It leaves behind trees of low vigor, and those do not produce very good seed. So cut over even age stands, you often have a problem in getting enough seed distributed across the site to create that new cohort. That's one limiting factor. Another is the presence of interfering plants in the understory, and that would be true. These stands that don't have a seed source often have beech in the understory, or ferns, or dense stands of raspberries, and that's a limiting factor you need to deal with. I don't think the deer, yes, the deer is an issue in many places, and the only way to deal with the deer issue is to reduce deer density so that the numbers of animals is below the capacity of the range to support them. Or fencing. In Pennsylvania, where they have some high-value cherry, they fencing. So factors like the abundance of the seed source or the lack thereof, the interference, the presence or absence of advanced regeneration, things like deer or other animals that would chew on the seedlings, those are certainly important limiting factors.
Okay, and then Tom Ward has two questions.
All right, yeah, Tom's first one I'm seeing is about, are there consulting foresters who carry this out, these treatments? And yes, there are consulting foresters who are starting to do it. We're really just raising awareness and people coming to recognize the need for this, but there are people who are doing it. We have them in New York. I know they're throughout New England and the eastern provinces of Canada. I can't sit here and give you names, that would be inappropriate, but my sense is that if you find a person who is experienced in doing silviculture treatments, not just engineering timber sales, but doing silviculture treatments, that person is capable of doing it. I guess that would be my short answer. And Tom also comments about favoring conifers for these drastic treatments. Hardwoods were tried back in the 30s and 40s, and they've not done very well on old field plantings. I must admit, though, that we've had very few examples of serious hardwood planting trials on cutover forest land. And it may be that if you planted hardwoods on cutover hardwood lands, they might grow better than what we saw in the past in old field plantings. We do have examples of planting conifers on cutover forest stands, and they grow much better under those conditions than we ever saw with old field plantings of conifers. So I would tend to favor the conifers. They're easy to handle. The probability of success we know is high, and we know what species grow appropriately under different soil conditions, and that will be a key in any planting. You must choose a species that's fitted to the soil conditions. So understand the soil drainage is probably the most important factor, and pick a species that's fitted to the depth and drainage of the site that you want to plant. You can mix hardwoods and conifers. You can insert conifers into hardwood stands and give you something that would be a mixed wood stand, and then treat them as mixed wood stands into the future. But I tend to think the conifers would be the safest thing. Yeah, there's things. Ronald, Ronald, you've got the question that's plagued a lot of us for many years, particularly in northeastern North America, where the availability of markets for low-value products has decreased, pulpwoods, for example. We see a few spots where biomass products can be sold. That's not caught on widespread yet. So you need to find a way to work with a contractor to get the work done, not worrying so much about revenues, but getting the work done in what I call a cost-neutral way. Perhaps seeing if you can trade the wood that's available for the work to get the trees cut. But cutting like these in the past has taken very little value you can now take out to help pay for these costs of operations. In the case of stands having no timber to sell, look for some of the federal subsidy programs. There's an individual up in Maine who is treating cutover areas where there's no standing timber left, and he is using, it's a consultant, and he's using some of these public subsidy programs to help pay the costs of getting that work done. Mechanized operations sometimes are more feasible than you can do by hand operation, and particularly if there's a safety issue. But that's going to be a big challenge. How do you get it done? Particularly since the values has been extracted already and you're left with the dregs. I'm sorry I can't give you more information than that. Caroline. Caroline is making a comment about how in the case of pine plantations, once they're thinned, hardwoods begin to form in the understory. We've seen that in New York as well, that white pine and red pine plantations and larch also, once you break apart the density of that upper canopy, the hardwood, sugar maple for us and white ash, begin to form in the understory. I don't know where the seed comes from, but it magically gets there, and you begin to see a mixed wood stand forming, such that if you maintain the thinning program and protected the hardwoods in the understory, you could gradually convert it to a mixed wood and then a hardwood stand. In the case of spruce, Norway spruce is our most common planted spruce. We've not seen this form. We have seen that in the case of Norway spruce, if we do a little bit of thinning in them, we can, once those stands are about 50 or 60 years of age, we can actually regenerate a new cohort of spruce beneath the old one. So I think we could replace those Norway spruce plantations with a new cohort of Norway spruce. Tom is asking about, yeah, the vigor of advanced regeneration and some of Gus Erdman's work. You have to distinguish between something that's reasonably young and small or something that's old and small. And this is the question you have to look at with, particularly with the shade tolerant species like sugar maple or red. If the tree has a long stem and just a couple leaves on it, and it doesn't, if it looks vigorous, if it is vigorous, it'll look vigorous. I can just pull out the seedlings and see what kind of a root system on there, but you just have to use your judgment about that it looks like it's got a decent crown. I would say the crown ought to be 25% at least of the total height of the tree. And that's really all I can comment, just to again, remember that Gus Erdman did used to warn about releasing things that were very old trees in the understory, and that's particularly true in even age stands where those sugar maple will hang on in a ½ an inch diameter, for example, and maybe 6 or 7 feet tall for decades. Potential for those.
Ralph, I've seen sugar maples that are in the understory, saplings or larger seedlings that have, you know, some of them still have a central leader and a seemingly pretty clear vertical trajectory, and others will, I don't know if you talk about it as the crown is flattened out or it's crowned out and it's kind of lost that central leader. Is that a reasonable visual criterion to use for evaluating?
That's a good one. That as these trees get larger and grow in beneath a dense overstory, the top of the crown becomes umbrella shaped, and once you see that, the vigor is losing, is being defaced. Now there's been some stuff that Dick Trimble published years and years ago. Give them light, those will often recover if they've got sufficient amount of foliage on them. So you ought to look for that flattened crown as one criteria that you waited too long to release them. But then combine that with whether there's good amount of foliage and good sized leaves, whether they would respond to release or not. Casey is asking about how do you know the age of a tree? If you look at an even age stand and compare the bark, say, of sugar maple of the smallest trees, the middle-sized trees, and the older trees, the bark looks very similar. It has that grayish kind of color to it, a little bit of ridging, a fissuring in it. If you look at a small tree in an even age stand, tall for its diameter, it has very little crown on it. Now go into an uneven age stand. The young trees will have a very smooth bark. In sugar maple, it'll be somewhat brownish. And then as the tree gets older, you begin to see fissures on it, ridges and more grayish brown in the color. But in managed stands, we found that if you look at the height of a small diameter tree, the height is short and the diameter is small, and the total length in foliage can be 50%. When you get to middle-sized trees, again, they're middle-sized in diameter, they're middle-sized in height, and again, the amount of the total tree in live foliage can be 50%. And the same with the older tree characteristics, and look for smoothness to roughness in the bark for a spread of ages to a kind of an old bark characteristic for trees of all sizes, as you would see in say 60 or 70-year-old even age stands that still have small diameter trees in them. Oh yeah, Tom is asking if desirable hardwoods will appear naturally in pine plantations, especially red pine, after the first thinning. Yes, they do up here in New York, and I've seen it in New England and many places. We will find that in red pine particularly, and white pine also, the common species forming in the understory after a thinning or some disturbance of the overstory will be sugar maple and white ash for us. In fact, those are the two species that commonly reforested naturally on old agricultural sites as well, and they've done very well on those agricultural sites from natural regeneration. I have no reason to think that they won't grow well after these pine plantations have been removed or died off. So we are getting some very nice hardwoods in the understory. Now the emerald ash borer. You know, the emerald ash borer is one of these natural disturbances that will probably cause us to use a multi-treatment approach. At least the stands that I've been looking at here around central New York, that appears to be, ash often tends to be in clusters. And if you are concerned about the loss of those trees of the emerald ash borer, you need to take out that whole cluster of ash, and that leaves you a big opening. In other places, there may be scattered as individual trees. But then you also have other trees that need to be taken out as a part of a management strategy for one reason or another. So increasingly, this multi-treatment option looks like one approach for dealing with the emerald ash borer. Rather than just cutting out all the ash trees, think about managing the rest of the stand as well. Now, in the case where you have done some sort of successful cutting and you have thickets of saplings, the common thing we've done in the past is just wait. As time will get bigger, you may find in a successful regeneration in hardwoods as many as 20 to 40,000 of them per acre. By the time that stand is 40 years of age, they're probably reduced to about 1,000. And by the time it's 60 or 70 years of age, they're probably reduced to about 800. And by 80 years of age, you're probably down to about 400 or 500. So in time, they will thin out. You can reduce the density of them artificially at earlier ages, but that costs a lot of money. So the general rule of thumb would be to let them grow until you have the mean merchantable height of clear length formed on the trees before you start intervention. That'll help protect the quality. So if you have a stand you think will, then wait till you've got 32 feet or 30 or 35 feet of dead length before you start doing intervention in the stand. If you want to do it earlier, you might think about sort of brush hogging. Take this mass of seedlings and artificially create rows. Just mow down rows, leaving an unmowed spot, and go over and mow down another, and create kind of an artificial spacing within the stand. Time will take care of a lot of things, though. Carmine is asking about the inventory. We've only begun to struggle with this question about how do you do an inventory. Talked about today. Historically, when we use an inventory to prescribe a silviculture treatment, we put in sample plots, enough of them so that we can define an average. What what is the single condition that we could create in that stand. Now we're talking about stands that have a hodgepodge of conditions from very open to very dense. And a traditional approach to forest inventory is not going to work. What we do in the field can be the same. We can use point samples or fixed area plots. But I'm beginning to appreciate that we need to take those data now and sort them into groups by, say, stand density. Which ones have hardly any trees, which ones have medium stocking, which ones have high stocking. And perhaps that, whether we've got 2 conditions to deal with or 3 conditions to deal with, and then within each of those groups that defines what we might call a condition class, then we try to develop a prescription for that, perhaps using standard procedures. So it may mean that we, instead of putting 15 sample points in the stand, we have to put in quite a bit more than that, and to give us a basis for sorting them out into these groups of plots that look alike or have similar conditions, and then making 3 prescriptions, each for a different condition class rather than single. That's essentially what Jean-Martin Lussier is doing up in Quebec, and it seems to work for him. It takes some experience, but he's doing it. All right, so Paul is asking about group selection. Silviculture is properly applied to uneven age stands, and group selection, as we know it, has its usefulness where you have a cluster of trees of the same age growing adjacent to each other. Often this is because there's been some sort of a patchiness created in the past, and you would identify the groups that have reached maturity and you would remove them to regenerate a replacement cohort, and then the groups that are immature, you do some tending. Mostly what I see people are doing is doing patch cutting, and that's different. A patch is an area of an engineered size and shape, and this would be done in even age stands. But you would decide what's the minimum size opening you need to create the environmental conditions to regenerate that new cohort. A general rule of thumb, I like to use tree height as a measure. A patch where the width of the patch is twice the height of adjacent trees. At the middle of that patch, you will have environmental conditions like large clear cuts. In most cases, a patch that's somewhere around 2/3 to 1 times the height of adjacent trees will be sufficient for regeneration of species like sugar maple and yellow birch and white ash. With black cherry, you probably have to go to those that are 2 times the heights of adjacent. And circular, round ones are easier to make than rectangular ones. So think about tree heights and multiples of adjacent trees, and I would suggest making a patch at least 3/4 the heights of adjacent trees. Try something like 3/4 to 1 time. Interestingly, with our northern hardwoods, where we get heights of about 90 to 100 feet tall, 1 times tree height is about a 1/5 acre patch, and that's been demonstrated to work quite well in regenerating both sugar maple and yellow birch. Todd is wondering about the response of sugar maple to growth response after release. I showed you from even age stands where the sugar maple was in the vicinity of 70 to 80 years of age. I've released 100-year-old sugar maple here in central New York and got good growth response that would be in the order of 2 inches in 15 years. In the central Adirondacks, back in the 50s, Farnsworth and Barrett released sugar maple trees that were about 200 years of age. And I measured them 40 years later and found that they went from a radial increment of about almost microscopic to 2 inches in 10 years, average for that 40-year period. The key is that the trees we're talking about here were in upper canopy position with the light. If you take those small trees in the understory, particularly of even age stands, they're just not going to grow. They do not have the potential. In uneven age stands, you saw the diameter growth curve that Diane Kiernan developed. In the uneven age stands, if you reduce the stocking to appropriate levels, those small trees will grow, as will the big ones. So I think the key here is you have to look at the condition of the crown and whether it's been in even or uneven age stand. But big trees big sugar maple will grow quite well if you give them plenty of sunlight. I think, Peter, that's the last question that I saw on the list.
And that's also what I see as the last question. So thank you again, Ralph. This was a great presentation, and thank you all for some really, I think, thoughtful and insightful questions. You're paying attention and asking good questions. That's an essential starting point. So we'll be back live again at 7 o'clock tonight, and you all that participated, of course, are welcome to come back, but it'll be the same presentation. So Ralph, you're going to stay connected, is that correct?
I will. I promise not to hang up.
Okay. I'm on campus right now. I'm gonna make you the host so that I can leave, shut down my computer, and then when I get back home, I'll connect tonight from home, and then I'll regain the host control and leave you as the presenter. So
all right. So I'll put a shroud over mine and come back at what, 10 of 7?
10 of 7 would be good. Turn your microphone off. And,
okay.
So let me, for those of you that came in maybe at the just after we started, here's the. Let me take over as presenter so you can see this. Okay, so now I'm the presenter. You should see a page that allows you to input your email address and first and last name. Martin was asking about this. Let me know, Martin, are you able to access this website? Input your email address, first name, last name, and then what credential you'll be using it for. Then there's a button in the lower right-hand corner you can click. Okay, Lou is asking if this material is covered in Dr. Nyland's silviculture book. I mean, Ralph would know that better than I. I think that some of this is more recent. I mean, the principles are all there in terms of manipulating stand density, but the specifics of rehabilitating cutover stands is, I think, more recent than at least the version of Ralph's textbook that I have. So. Okay, well, I'll give you all another few minutes to hit this page here. I'm going to turn the recording off.